Welcome to the webinar on Swarm 8 that we just launched earlier this week, 2 days ago on Tuesday. The focus is all about enabling searchable storage for the cloud age. My name is Adrian Herrera. I'm the VP of Marketing. I have Tony Barbagallo, the VP of Product, with me. Say hi to everyone.
Hi there. Hi, everyone.
So before we start, just a little housekeeping. Feel free to ask questions throughout the webinar. We'll have the question panel open on our end, depending on where you have it on your screen. It's usually on the right. Just go ahead and feel free to type them in, and we'll answer them throughout the webinar. If we don't get to your question for some reason, there will be a Q&A section at the end. We're pretty excited about this launch. It is rather significant. So with that, let's go ahead and get started. So before, we'll do just a real quick overview on the company, who Coringo is. If you're attending this webinar, you probably know us. We've been around for a long time, just really always focusing on storage software. Founded in 2005, we've been able to continue to innovate and harden our product for the last decade. And part of that innovation will come out in what you're about to see, what Tony's about to show. We are a recognized leader in the space. We work very hard on integration to the most popular enterprise and cloud applications out there. And we are enterprise grade. We're used by very large organizations around the world, like the Department of Defense, Department of Justice, but we're also used by some of the most rapidly scaling and cloud companies out there, like Match.com, Ask.com, 2.com, Rightmove, and others. So anytime you need massively scalable storage that's accessible, economical, and now searchable, we are the best solution in the market. And with that, I'll kick it off to Tony to walk you through what's new in Swarm 8.
Great. Thank you, Adrian. There we go. So, very quick highlights, and then I will spend about a PowerPoint slide worth of time on each of these points. That they're essentially somewhat ordered in priority of importance and level of effort for our team to add the capabilities into Swarm 8. One of the first things that we've done, and some of you may have known that we've had an integration with a search and indexing capability in the product. We've now fully productized that as part of the platform, fully integrated a search engine based on Elasticsearch into the storage platform. I'll talk about that in a second. We've actually created a new web-based content portal, and this is really the basis for our work in building a single pane of glass view into the storage platform, and ultimately it will include complete storage cluster management. What you're going to see now is content capabilities in terms of uploads and searching on metadata, as well as setting permissions on domains and buckets, etc., which I'll talk about in more detail. Lastly, we've added some additional capabilities which continue to sort of cross the boundary between object storage and legacy file storage. We've added inherent in the product object versioning, as well as atomic object rename, and I'll talk about those as well. And then finally, and for those of you that have been with us for quite some time, you'll know that some of the capabilities in Swarm have been licensed separately, and what we've done in Swarm 8 are all the core capabilities in Swarm now are just all together in a simple bundled configuration. So that includes the items that I'm talking about, as well as erasure coding, indexing, CSN, etc. So they're all together as a single bundled SKU. And then lastly, for those of you that perhaps followed our launch of FileFly back in the summer, all of Swarm 8 is out of the box integrated with FileFly, which is really automating the action from traditional file servers and migration over to Swarm object storage. So with that, I'll dive into each one of these. The first one, Swarm Search. As I mentioned, this is based on Elasticsearch. So if anyone is familiar with Elasticsearch, anything you can do with Elasticsearch, you can do with Swarm Search, including, for instance, Kibana as an analysis, a graphical analysis engine on the front end. So what do we offer? Basically, actionable insight into the data in your cluster. Targeted analysis, you know, as you get more and more objects, typically object storage is associated with massive amounts of objects, bordering on, you know, big data type of projects. So within Swarm, you can classify on keywords, descriptive content, multiple ways to track content, and because now this is all integrated, you really have no separate, no need to, for instance, migrate your data to a separate sort of big data database to do any kind of analysis. It's all contained within the storage system. On the far right there, I have an example of some of the command line calls, again, all based on HTTP calls. So for instance, I showed some examples of the calls you would execute to list domain objects within a cluster, list buckets in a domain, list objects within a bucket. So those are various types of examples. Of course, JSON objects, also XML will work, and you know, using our SDKs, if you've built any native applications, this is all works at the, if you will, at the DevOps level. And probably the most interesting one is, and where we think will ultimately have the most power going forward, is the ability to search for objects with specific metadata and pattern matching of custom metadata or metadata that is inherently included with the product. So this is all very interesting for those of you that are writing native applications using our SDKs at the command line. What you'll see coming up, though, is our new user interface that we've built, so you can get a sense of how all this works with a point and click. And that's what we're calling our Swarm portal. Some of you may have known it in the past as Cloud Scaler. Again, though, this is now completely part of Swarm 8, and again, all licensed as one complete package. So the portal, and we've added some significant new capabilities. You can now organize and search data with what we call collections. Collections are essentially the equivalent of smart folders in the file system world. But you can do dynamic metadata query and search. You can create relationships across data sets, so you can actually have collections of collections. I'll show you an example of that on the next slide. Also within the portal, as I mentioned, you can manage storage, roles, and access. So integration with identity management. You can actually delegate administration, say, of lower-level domains and buckets, so that end users can do their own management, but are not able to perhaps access the higher-level domains or tenants in a particular environment. And also usage metering. So if you're an MSP or an enterprise that needs to show chargebacks or showbacks, we support usage metering down to the tenant storage domains and even the bucket level. And this is all accessible with our new web-based API, as well as a complete management API that we built to enable our web-based UI. And we made it a very clear direction to the UI team that anything that they're showing in the UI had to be requested through the API. So if they needed to show something that wasn't in the API, the platform team had to add it to the API. So we made sure that this API is completely usable and, for third-party user interfaces and/or integratable with, say, billing systems, etc. So here's an example of collections that I mentioned. And it's really about organization and search at scale. Excuse me. So what I'm showing here is an example of some medical images. And again, it's a very simple example. You'll see the screenshot in the back shows 113 search results of some medical data in a particular in the particular domain that I have here. And I've created that collection called medical data. And now what I'd like to do is narrow that down to only show a certain area of the body and a certain case number. You'll see the metadata on the right side, the typical metadata associated with an object, size, type, owner, stored data. And recall that this metadata is encapsulated with the data in an object in our storage cluster. So there's no separate relational database that stores the metadata. It's all contained within the object in the cluster, which allows some pretty sophisticated custom metadata to be added to the objects for searching and as well as general housekeeping and performance. So I had clicked on what used to say more, and now it says less, and you can see some of the housekeeping metadata. And then the interesting things are at the bottom, where you see X body region and X case number. Excuse me. Both of those are custom metadata. You can actually call your metadata anything you want and assign values. So essentially we have kind of key value pairs here. So what I've done is I've said I would like to create a new collection based on the body region and the case number. And what you see is a screenshot on the left where a new search template was created. You'll see it was based off of the original collection, medical data, where it was searching the entire domain for JPEG images. And now I've added that it was the software, the user interface automatically added based on my clicking and creation of that collection, the body region, which equals neuro, and the case number, which equals 805. I do a refresh, and you'll see that resulted in 17 results from the original search results of 113. So very simple point and click. In the same user interface, I can also upload data. Of course, you can do bulk uploads with shell scripts and curl commands if you have lots and lots of objects to upload, but you can also now use this tool to do drag and drop uploading of data. We actually use it internally to pass PowerPoints like this around amongst the employees, etc. So it's a great front-end tool for the back-end object storage environment.
Hey, Tony, we have our first question.
Sure.
Basically, is all of this available via a RESTful interface, RESTful API?
And the answer is yes, it is. Everything that you're seeing in this UI requests are being made to our API to generate this information that you're seeing in the web-based UI. And not only the content part, but also this management capability as well. So the slide here on multi-tenant management capability. We have connections to LDAP, Active Directory, Linux, PAM. We also do token-based authentication, and again, through a full RESTful API and/or this web portal. We have flexible naming scheme. There's no bucket limit. You can use your domain. Completely interoperable. HTTP, our own protocol. The S3 protocol we work with, HDFS, NFS, SMB, etc. What I'm showing here is the creation of a token. So I've created a tenant for a fictional company called ABC Manufacturing, and now I want to create a token. I can also set properties on this tenant, permissions on this tenant as well. But in this particular example, showing this new token here, you can see I created a token, I've given it an expiration date, and I've decided to create an S3 secret key, which means that I probably want to use this token either via an S3-based browser or with the S3 protocol. I simply click create, and that's as easy as it is to create a new token for this particular tenant. So next is object versioning. You know, and in the past, and typically in object storage systems, anything that has to do with versioning is sort of left as an exercise to the application to take care of. What we've done in version 8 of Swarm is we've added inherently the capability to create and maintain old versions of an object. And you can see here in the pictorial at the bottom, version 0 going to version 3, and then maybe you deleted it, and you're basically over time creating these new versions. This is enabled on a per domain and per bucket level, all completely tunable by the administrator, so you can keep as many or as few old versions as needed. You can go back to old versions. So, you know, what do you gain from this? Revision control, being able to roll back changes or undo deletes, read and copy old versions, and again, this is fully S3 protocol compatible. So just like the version capabilities in S3, we've maintained that compatibility with this feature. And lastly, as again we continue our integration with file protocols, our object rename is now an atomic operation. So again, typically in an object storage platform, to rename an object requires a copy of that object, and then a paste of that object with the new name, and then a delete of the old object. So while it gets the job done, it's in general a low-performant way to accomplish rename. So this capability now extends the reach of our renaming capabilities. In the past, we've been able to rename domains and buckets as a single high-performance operation. Now we're able to rename at the object, right at the object level. So this is really a basis for file integration with file-oriented protocols, like, for instance, NFS, etc. And you'll be seeing some of that additionally as we go forward throughout the year. And lastly, we've created the ability to support alternate character sets. So on the object naming, the metadata, and the searching. So this allows for internationalization and localization of any applications on the front end to the object storage platform. That's a quick high-level overview of the new capabilities. Remember, it's really this version 8 has really been a focus on enabling search as we continue to progress forward in the evolution of object storage. You know, we've been at it, as Adrian mentioned, for over 10 years now. We have a number of very sophisticated storage level capabilities, and we felt that this was the next big step in object storage, to be able to integrate NoSQL-like search capabilities directly into the platform. And again, all of this is integrated with FileFly. And FileFly, for those of you that may not be aware, but it's a quick review, we announced this again last summer. FileFly is essentially our bridge into traditional file server, if you will, thin provisioning. So FileFly is an application that runs on a Windows server or in a VM. basically allows for transparent file access. It plugs directly into Windows and NetApp file servers, and then really what we offer is similar to the notion of thin provisioning your LUNs or your storage area network devices. With FileFly, you can thin provision your NAS servers. The typical use case is that as files become less and less accessed over time, they are transparently migrated off of your primary servers and into Caringo Swarm. If they then are accessed at a later date, they transparently migrate back to the primary file server as if they've never been gone. So once you've done this migration, you can certainly free up, especially based on some of our statistics that we've gathered in our research we've done with storage administrators. You may be able to free up with a policy such as remove all files or migrate all files that haven't been accessed in the last 30 days. That may free up a good 60 to 80% of the storage consumption on your primary file servers. So what happens at that point is your backups get streamlined, and of course, once all this data is on Swarm, because our object storage environment has inherent data protection in terms of replication or erase or coding, there's no other backup required. This data can actually be read directly from the object storage environment. So if you have a native application, or even with our content portal, our Swarm portal that I just talked about, you can actually see all the data that has come over, assuming you have the correct privileges, of course. You can actually see all the data that has been migrated over from FileFly. So that's part of the complete seamless integration. You can see it on both sides, either on the Windows or NetApp side as well as on the object storage side. And so this just gives a overview of the architecture in a pictorial way. This is also on our website. You can see where we're evolving to. We have the capabilities and the tiering from filers and general native applications on the top. HTTP is a protocol, S3 compatibility, OpenStack Swift through a plugin. We support Hadoop with our HDFS connector, Windows and NetApp, as I mentioned. We have the multi-tenancy, the storage cluster at the base with integrated search, and our portal that manages all the action from a web-based user interface standpoint, as well as the RESTful API, running on any mix of x86 servers, now virtual machines. And for those of you that don't know, about 3 weeks ago, we announced that Swarm is available on Microsoft Azure. I'll just give a quick plug on what we've done there, but it's a complete environment. It's on the Azure Marketplace. You can just go to the Azure Marketplace and search for Swarm, and it'll show up. We've created some templates there if you're an Azure customer and understand it. So there's a 16 terabyte, 32, and 64 terabyte Swarm cluster that have been created as templates. Of course, you can expand on that space. The way we're doing it is with the bring your own license model. So if you already have a Swarm license, or if you need a new Swarm license, you're good to go. Then you just basically provision your VMs as you would in Azure, just as you would for any other type of application. And there you have it. So that's essentially the quick overview of Swarm 8. I hope this has been helpful, and if there's any questions, we're happy to take them.